Okay, today we are going to do 4-3 prime factorization in GCF. And GCF stands for greatest common factor. So let's talk about, we've talked a little bit about what a prime number is, but a prime number means that a number only has two factors. And those two factors are 1 and itself. So some examples of that are 1, 2 is the only even prime number, 3, 5, 7, 11, 13, and on and on and on. Okay? Composite are numbers that have more than two factors. So if it's not a prime, then it's composite, more than two factors. Okay, so that could be for any other even number, 8, 9, and so on. There's obviously a lot of those. Okay, prime factorization is the product, and we'll do this in a minute. Product of prime factors. It's a way to break down a number into prime numbers, product of prime numbers. So we will get to that in just a minute. Okay, so prime factorization, which is also called the factor tree. So you might have heard it called the factor tree. So when we do prime factorization, basically we're just breaking down the number. And you'll notice that I have 3 60s here. That's because you can do 60 a lot of different ways, but you should end up with the same answer. So you could divide 60, so you just come up with two numbers that multiplied together give you 60. Well, that could be 6 and 10. And your goal is to get it until they're prime numbers. So 6 breaks down to 3 and 2, 3 times 2. 10 breaks down to 5 and 2. Okay, so how you do prime factorization is any pair. Oh no, that's totally, I'm thinking the wrong thing. So I'll do that in a minute. So prime factorization is 2. There's 2 of them. So 2 times 2 times 3 times 5. So you do it until they're all prime numbers down here. And depending on the directions, sometimes you'll leave it like this. Other times you'll go ahead and make this 2 squared. And you do not put 4 because you want it to stay prime. So either one of these are right. It just depends on what the question's asking. Okay? So I'm just showing you here that you don't necessarily have to start with 6 and 10. Okay, you could start with 2 and 30. 2 times 30. That 2 is already prime, so we're just going to leave that there. This could be 3 and 10, or it could be 2 and 15. It doesn't matter. You'll end up with the same answer, and then 3 times 5. So again, you have 2 squared times 3 times 5. And you want to get in the habit of making sure these are multiplied. Okay, it's multiplication. You can put little x's there if you want. You're not just writing the numbers down. They're actually multiplied together, because 2 times 2 times 3 times 5 will give you 60. Okay? And you could even do, you could even do 3 times 20. And then break 20 could be 5 and 4, or it could be 2 and 10. It doesn't matter. Again, you're going to end up with the same answer. So we have 2 squared times 3 times 5. And you notice that I put them in order as well. Okay, that's going to come in handy. So make sure you put them in order. Okay, so let's try this next one, 42. Again, you could do it a few different ways. Okay, we're going to do 2 and 21, but you don't have to do it that way. Okay, so 2 is prime, so we work on the 21, which is 3 and 7. Okay, so then when you would write it, you would do 2 times 3 times 7. Remember that you're multiplying those. Again, you are not adding those. You're not just writing them with a comma. You're multiplying those together. Okay? So that is the factor tree, or prime factorization. Now you can find the greatest common factor using prime factorization. And I'll show you in a minute how you used to, or you normally find the greatest common factor. This is another way, and sometimes this way is a lot easier when you have really big numbers. Sometimes the other way is easier. It just depends on what they're asking and if they tell you a certain way to do it. So we're going to go ahead and, because it says find the GCF using prime factorization, so that means we're going to listen to the instructions. So when we break down 40, you could do 2 and 20 or 4 and 10. 4 breaks down to 2 and 2. 10 breaks down to 2 and 5. So we have 2 times 2 times 2 times 5. On these, it's just better to leave it without the exponent. Okay, and I'll show you why in a minute. So when we break down 80, where am I looking here? When we break down 80, you could do 8 and 10. You could break that down a few different ways. 2 and 40. Okay, let's just do 8 and 10. If you want to do it the other way, that's fine. Then we have 2 and 4. This one's a kind of bit of a longer one. 2 and 2. And 2 and 5 over here. So now we have 1, 2, 3, 4 twos. So 1, 2, 3, 4, whoops, 4. And then times a 5. That's a times in there. So what you're going to do, the easiest way is to then bring this and put it under it and line it up. 2, 2, 2, and 5. So what you're going to do is you're going to circle the pairs. Whoops. My marker is not working for me very well. There we go. So we have 2 times 2 times 2 times, I'm having trouble today, times 5. So 2 times 2 is 4, 4 times 2 is 8, 8 times 5 is 40. Now, if you remember what GCF is, you could have looked at this from the beginning and known that it was going to be 40. And that is fine unless it tells you have to use prime factorization. If you have to use prime factorization, then you have to do it this way. So you see we pair them, and then that, it just becomes, each pair becomes 1. 2 times 2 times 2 times 5. So the GCF is 40 for this one. Now where sometimes this helps is when we throw variables in there. So you're still going to break down your 6 to 2 and 3, and you break down your 4 to 2 and 2. So then when we write this, we have 2 times 3, and then we have 3 A's. Okay, so we have A times A times A times B. And over here, we have 2 times 2 times A times A times B. Okay, so we're going to put them under each other. Doesn't matter which one goes where. I'm going to go over here because I have more room. So 2 times 2 times A times A times B. Okay, and that's just because I took the A squared and made it A times A. And you circle the pairs. So we have that pair, we have 2 A pairs, and we have 1 B pair. So what do we have? We have 1, 2. We have 2 sets of A's, so that's going to be A squared, and we have 1 set of B. So that would be your GCF. Okay, that would be your GCF. Next. Okay, so this one says use any method to find the GCF. So if you are looking at this and you know that you can either do the factor tree, which we just did, or you can just list the factors. So we know it's 1 and 30, 2 and 15, 3 and 10, 4, 5 and 6. Okay, so we know these are the factors here. This is 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, or you could just put 6 ones. And then you just find the biggest one that they have in common. Okay, well, the biggest number that I see that they have in common is the 6. So we know our greatest common factor is 6. Okay, so when it's kind of smaller, more common numbers, it might be easier to just do it this way. Okay, if it doesn't tell you, you can do it any way you want. Okay, now if you're going to look at these, again, you could list the factors of 12. 1, 12, 2, 6, 3, and 4, and 15, 1, 15, 3, and 5. So we know the number is going to, and you might be able just to look right at the 12 and 15 and know that the greatest common factor is 3. That is fine. But if you don't show your work, I can't give you credit. So, and then we look, what do we have in common? We have 1x here and 2 x's here. We have 1b here and no b's here. So what do we have in common? We have 1x is the only thing we have in common. So the greatest common factor would be 3x. Okay?